Hello, everyone. This is Uzair from the Encash team. With me today, I have our Senior Solutions Architect, Ron Hussein. Welcome to our webinar. Today's webinar is going to be on scaling your ASP.NET Core apps with Encash. Now, before we get into it, as always, we just want to wish everyone good health and safety during these uncertain times, and always, remember to take a little bit of time for yourself during these very busy work weeks. So in today's webinar, we're going to be doing an overview of ASP.NET Core scalability and performance bottlenecks, and how distributed caching resolves those bottlenecks and other issues. This is a listen-only webinar, but anytime during the webinar, if you have questions, you can use the GoToWebinar Questions tab to type in any queries you have or any questions you may want answered, and I'll be keeping track of them and bring them up during the webinar to get them answered. And also at the end of Ron's presentation, we'll have time for Q&A to answer any questions and queries you may have. All right, and without further ado, Ron, I'm going to hand it over to you.
Very good. Thank you, Zair. Hi, everybody. My name is Ron, and I'll be presenting this webinar as far as all the tech details are concerned. As Uzair has already mentioned, the topic that we've chosen today is a very popular one. Uh, we are going to talk about ASP.NET Core applications, what are their performance and scalability bottlenecks are, and then we will talk about how to resolve those performance and scalability bottlenecks with the help of Encash distributed caching system. Encash is an in-memory distributed caching system for your .NET and .NET Core applications. It's written in .NET and primarily for .NET and .NET Core applications. But primarily, today's focus is going to be around ASP.NET Core web apps, and I have a few sample, features available. I have lined up some sample applications as well. So it's going to be a hands-on webinar where I will share some feature level details of different use cases that you can capture, and features which are there to help address those use cases, and I'll demonstrate those samples as well. So I believe everybody can see my screen and hear us fine. So if I can get a quick confirmation in the questions tab, if you guys can see and hear everything fine, please confirm, and we'll get started with this. All right, so I've got a few confirmations, so I think we're all
Yep.
set. Let's get started. So first few slides are introductory slides about ASP.NET Core platform in general. I'm pretty sure everybody knows what ASP.NET Core is. It's the new ASP, web application platform. It's clean, lightweight, modular. It's primarily MVC architectured as far as web application approach is concerned. Uh, the popular front end, Angular, React, it's mostly JavaScript based front end, and then MVC architecture to back it up. It's cross platform. You can run it on Windows, Linux, and any other operating system such as Mac OS. And typically it's something which is very compatible with legacy 4.8 4.0 ASP.NET applications as well, where if you have an ASP.NET MVC application, now you can migrate off of that and start using ASP.NET Core technology for that matter, which is very fast, very robust, and very lightweight and clean architecture in general. First thing that we'll talk about ASP.NET Core platform is, it requires scalability. So let's define what scalability is. Any application which is running under normal user load, and by normalized I mean some users are there, let's say 5 to 10 users are logged in, and they're performing certain transactions, certain operations, read and write requests. Typically, idea here is that your application would be super fast under low user load. But as soon as your application load grows, and that's something which is a requirement for the business as well, that you need to have more and more users logging on to your applications, that's when your applications tend to slow down. There could be slow performance under peak loads. If your application is not able to maintain same performance that it had with low number of users, and then when it has the high number of users, if it is able to maintain the same performance, that application would be categorized as a very scalable application. So the architecture has that ability to scale out and be able to handle the increased load from your end users. So high performance under peak loads is what actually defines the scalability factor. Here is a graph. Typically, scalability is achieved within ASP.NET and ASP.NET Core platform through web or app servers. You can distribute your application load. You just deploy your application on multiple web or app servers, and based on that, you simply distribute your application user load onto those servers. And as you add more servers, you get a linear improvement in request handling capacity. More servers mean more request handling capacity out of your application. And here is a non-linear scalability, where even after adding more servers, the architecture is not designed in such a way that although you're adding a lot of web servers, app servers, but your applications are not scaling out as your user load is growing. So your transactional requirements are growing, and you're adding servers, you're doing all the right steps, but you're still not able to gain the capacity that you need to have to accommodate the increased request load. So that problem is actually typically associated with backend data sources, and I'll talk about it. So first of all, let's see what applications need scalability. What are the different kinds of applications? Within ASP.NET and .NET Core, we have web apps, an MVC web application running the main business, some web services, some service calls, some microservices. That's the new architecture, and it could be any other general .NET or .NET Core application. All of these demand scalability because you may have a lot of internal or external users or request load happening, which needs to be fulfilled by your application architecture. I mentioned that you can create a web form, you can distribute your application load on multiple servers. So where exactly the scalability problem is? As you can see, if you add servers, you should be able to handle more and more request load because it gives you a linear scalability as far as app form or web form is concerned. But when exactly you start seeing a non-linear scalability or no scalability at all? That is typically with relational databases. Your application tier scales out nicely, right? You can add more servers, you can create multiple instances of same application on the same box, or you can have separate boxes hosting your applications. But all of these applications normally talk to a backend relational database, and relational database is very good for storage. But when it comes to handling extreme amount of request load, for example, you have a lot of transactional load happening on your applications, that database becomes a bottleneck. It's first of all going to slow things down, so it's a performance bottleneck, and then it does not have capacity to increase the scalability of it. It does not have any ability to increase capacity. It would just give you the capacity of the given server where the database is hosted. It could also be some mainframe database, it could be some file system. All of these sources are a scalability bottleneck for your application, and that's where your applications slow down, your requests start to queue up, and overall end user experience is impacted by that. NoSQL isn't the answer. I understand that a lot of NoSQL products are there. We also have a product called NosDB, which is a NoSQL database. But the main problem with NoSQL databases is that your applications would require a re-architecture where you stop using a relational database and start using a NoSQL, unstructured data source in comparison. So re-architecture of the application is not easy as well, right? So that's another problem that you need to take. So overall, your applications are not scalable primarily because of backend data sources. What is the solution? It's very simple. That you start using a distributed caching system like Ncache. It's in memory, so it's super fast in comparison to database. So that's the first benefit that you get out of it. Excuse me. So with in-memory access compared to disk-based access, Ncache is super fast in comparison. So first benefit, your regular application requests going to Ncache in comparison to database are going to be super fast, and it's going to take load off of the database as well by saving trips to the backend data sources. So your database is free to do other things as well. Second benefit of it is it's very scalable. It's linearly scalable in its model. It's not just a single server. There are multiple servers which you can use to host your cache cluster. It's a cache cluster. So team of servers work in combination to one another and help serve your client requests. More servers mean more request handling capacity out of Ncache, and that's where it gives you huge benefits, where not only you get super fast responses out of Ncache, it's super fast, low latency, and it also gives you high throughput, extremely high scalability, You can keep adding more servers and you can linearly grow that capacity whenever your user load grows without changing anything inside your application architecture. And nice thing about Encache is that you use it in addition to a backend database. It's not a replacement of your conventional relational data sources. We don't have to re-architecture the application to start using Encache. You can always use Encache in combination to a backend data source where some or most of your data is inside Encache and database has master copy of it. But for some use cases, cache would have all the data, uh, for example, for sessions and for other use cases. Here are our throughput numbers. We conducted these tests in our AWS lab. This was a real life application data simulated in our AWS lab. So it's not a touch and go data, actual application data simulated in our environment, where we used 5 Encache servers and we were able to achieve 2 million requests per second out of Encache. So that's the kind of performance improvements you have if you or scalability numbers you have if you have more and more servers added. So 2 million requests per second with just 5 Encache servers, and it was a very linearly increasing trend, and it should kept on increasing if you keep on adding more servers. These are published on our website as well. There's a video demonstration available as well. Here's our deployment architecture. Typically, this is how Encache distributed caching system is deployed. It is supported on all environments, on-premise as well as in cloud. You just need .NET or .NET Core framework to be available. That's the only prereq for Encache, and you can deploy it on Windows as well as on Linux servers. It could be your physical or virtual boxes on premise, or it could be any public or private cloud where you have .NET or .NET Core installed on Windows or Linux. So these are two requirements. Other than that, Encache is supported on every platform. It's available on Azure Marketplace as well as AWS, and we are also coming up with SaaS-based model or deployment of Encache in our upcoming versions. There are two deployment options. One is that you use dedicated servers for caching and your applications connect in a client-server model. That's the preferred model in cloud as well, where you don't have client-side VMs, but you do have server-side deployment. And the second deployment option is that you use your existing application boxes as your Encache servers as well. That's mostly on-premise where you have application tier already there, smaller configurations. You might want to use Encache to be installed on the same box, same set of servers. In either way, Encache handles most of your traffic. 100% is recommended, and some traffic can always go to the backend database, and these could be your transactional operations, write operations, which you can handle through cache to backend data sources. So you can either use cache aside pattern where your application adds data and updates data or fetches data from cache and the database in conjunction with one another, or you can use read through and write through approach, which is also available with Encache. I'll talk about some use cases and then we'll jump right into our ASP.NET Core specific caching features. Any questions so far, please let me know. I think we're good. So let's talk about some common use cases of Encache. There are many use cases, and from a technical standpoint, I have listed a few. And these are specific to ASP.NET Core applications, but in general, for any .NET or ASP.NET or ASP.NET Core or .NET Core, it could be a web application, some backend applications, some workflows, some Windows services. Any application can utilize Encache, and there are many use cases that you can choose from. Primarily for ASP.NET Core, we will target app data caching, and in this we have two options. You can use iDistributed Cache interface. If you're already using iDistributed Cache in your applications, you can simply plug in Encache as a provider for that. So that is first option. Second option is that you use direct Encache APIs. And in app data caching, you cache almost anything inside your application. It could be your domain objects, collections, data sets, any data that you would like to use more than once, and you don't want to go to the backend database. You have retrieved that data, and now you can preserve that data in the cache, and you can keep using the cache repository and save trips to the database. Second use case is ASP.NET Core specific caching. These are our web front-end caching features. On this front, we have a lot of features. You can use ASP.NET Core session state. It's a single site and multi-site sessions. Encache is a distributed cache cluster, so your sessions are stored in a distributed manner inside Encache. It's also a no code change option, almost with one line of code change, an extension method where you plug in Encache. No extensive code changes are needed in order to use this. And these are very reliable inside Encache because sessions are replicated across servers. So any server going down would not have any data loss or application downtime on your end. Second feature here is ASP.NET Core Response Caching. If you have static pages, historically in ASP.NET we had output caching. In the newer ASP.NET Core platform, you can use the response caching where you define page level headers, and based on those, all those page outputs are cached inside Encache. So responses are cached. If you issue exact same request again, you get the pre-cached response made available. So that's a feature within Encache, which is also a no code change option that you can use on ASP.NET Core front end caching level. And then if you're using SignalR, and if you have a web form, you need a backplane as a must. So SignalR backplane is required if you go from a single server to a web form deployment. And in that case, Encache can act as a ASP.NET Core backplane, SignalR backplane for your SignalR applications. It's using PubSub messaging behind the scenes, which are event driven, very fast, very scalable. So you get benefits of high performance and scalability and high availability and reliability if you plug in Encache as ASP.NET Core SignalR backplane. Finally, the third use case is PubSub messaging. PubSub messaging is a separate use case as well. For SignalR, behind the scenes, we're using PubSub messaging, but PubSub messaging can be used as a separate use case within Encache as well. For microservices application, this makes a lot of sense, where you have simple applications defined under microservices architecture. Those are responsible for a dedicated task, a very important purpose that they're serving. So it is very difficult to arrange communication between those microservices, and Encache can resolve that problem. You don't have to implement any communication within your microserver services applications yourself. You can rely on Encache communication platform for that, and any application connected to it can send and receive messages, and it doesn't have to have any performance degradation while they're doing it. You can have publisher subscriber model, where publishers are publishing data to the cache, and then cache is storing and relaying those messages to all the subscribers. It's an async event driven mechanism, so publisher and subscribers don't even have to know one another. So there are no latency, no wait involved, no synchronous calls involved. So it's very robust, very fast, loosely coupled architecture, and everything is managed by Encache as far as this platform is concerned. So we've covered these high level features. Next, I'm going to show you the actual product in action, where I'll create a cache cluster, test it, show you some monitoring aspects, and then we'll talk about all these features that you can use in ASP.NET Core one by one. So I have lined up some sample applications for that. So I'm logging onto my demo environment. So here we have two Encache servers which I'll be using, and my box would act as a client machine from where I would run all these sample applications. So idea here is that I'm going to use the web-based management tool and monitor tool. And by the way, if there are any questions, please feel free to let us know, and I'll be very happy to answer those questions for you. Right. So this web-based management tool allows you to manage and monitor everything from a single point. It could be any web request, HTTP request from anywhere from your environment to one of your Encache servers or clients, and it should allow you to manage and monitor everything remotely through web. So localhost, you can give an IP address and you can just access this resource from anywhere over the internet. So I'm going to go ahead and create a new cache. Let's say ASP core cache. All caches need to be named. You can create multiple cache clusters as well, and you can come up with any meaningful cache name as needed. Mode of serialization could be binary or JSON. So I'm going to stick to binary, and then JSON is also very flexible, so if you would like to use that. And then I'll pick partition of replica cache topology. Within Encache there are many caching topologies. If I quickly take you to towards the end, So we have many caching topologies to choose from. We have partition, and then we have partitioning with backups. So in this, we have each server maintaining two partitions: an active data partition where clients are connected, and a passive replica partition of another server. As you can see, server 1 is active, its backup is on 2, and server 2 is active, its backup is on server 1. In case any server goes down, the backup gets activated and you get all the data from here. Under normal operations, these partitions are having equal distribution of data. Clients are connected to all the servers, so read and write requests are super fast. And if you add more servers, you get more read and write request handling capacity because all those servers work in combination to one another. So that's the topology I'm choosing. Partition of replica. And then async replication option between active and backup. You can choose sync or async. Sync is more reliable, async is faster. So I'm going to go ahead with that. Size 1024 is good enough for this demo, but you can come up with any size that seems meaningful to you. TCP parameters. Is there a question?
Just a quick question. A couple came in, but I just wanted to throw one your way. One of the attendees says, well, we're currently using Encache. Is there a way to avoid a client.ncc or ncconf file or something that you have in your development pipeline?
Yes, that's absolutely possible. Client.ncconf allows you to specify configurations to connect to a cache server where the cache cluster is running, right? In my case, I have two boxes and a cache name. So client.ncconf has the cache name and the servers where this cache is configured. If you want to avoid client.ncconf, you can provide all these settings inline. We have cache initialization params. We call them cache init params. Those are that object allows you to specify all these configurations within the application code. So yes, to answer that question, you need to use cache init params.
Okay, and we had just one more come in. It was, can we deploy Encache in Azure?
Absolutely. I discussed this when while we were sharing details about deployment architecture. Encache is fully supported in Microsoft Azure and AWS and any other public or private cloud. Only prereq for Encache is .NET or .NET Core, depending upon operating system that you choose. We also are coming up with our SaaS model within Azure and AWS, so it's fully supported. Our marketplace image is also published. So there are many ways you can use Encache in Azure.
Okay, all right. I'll throw some more later, but I'll let you get back to it.
Very good. Okay, so Encache is a TCP/IP based cache clustering protocol, so it requires an IP address and a port. So I'll just keep everything default on the screen. If my cache becomes full, I have two options. I can reject new updates and keep using cache for reading, or I can turn on evictions and it would automatically remove some data to make room for the newer items. For sessions, for view state, for response caching, and even for object caching, if data is of important nature, I highly recommend that you turn off eviction and provide a big enough cache size so that it never becomes full. And even if it becomes full, you can change the cache size at runtime. But if it's okay to afford, it's okay to actually lose some data if you can afford that. So in that case, you can enable evictions, and at cache becoming full, it will automatically remove some data and make room for the newer data. So that's what eviction does. Start this cache on finish and auto start this cache on service startup. So each time my server gets rebooted, cache would automatically be started up. And that's it. That's how easy it is to configure a 2-node cache cluster with Encache. So our cache is up and running. It's activated as well. So I'm going to quickly go ahead and test it. Statistics window. So these show me perf counters of both servers, and then monitoring aspects of Encache. Very good. So it gives me server side and client side dashboard, report view as well. So all the parameters are there. Next thing is to test this cache. No application is connected, so I'm going to go ahead and do that. So let me have controls back. For some reason it got stuck here, so please bear with me. Oh, finally here. that's the name of the cache. And behind the scenes, this is using client-side configurations to connect, and would connect to my cache cluster and start simulating requests. As you can see, request per second counter and average microsecond per cache operation counter showing activity. We have additions, fetches, updates happening as well. And we have cache size counter showing up, CPU, memory, and we have client IPs which are currently connected to the cache. Let me go ahead and run another instance of this tool. Right. Please go ahead, Uzair.
Another question while you were doing this is, can we monitor all the clients connected to our caches?
Absolutely. That's one of very powerful features within Encache. I can show this with the help of this example. Now that we have two clients connected, first of all, I can see the client dashboards. So these two clients are being run from 107, and I can see read operations being made from this client box. If I'm running applications from my box, which I would do, you would see my box statistics here as well. And similarly, we can also see the processes, their process IDs, ports, bytes sent and received from here as well. But I think main thing that you're looking for is different monitoring aspects from the client side. So we have read operations per second, additions per second, updates per second, fetches. So we have complete set of client side counters which are available as part of Encache, right? And cache health, and these are all server side counters, but all of these counters that you're showing under client side, these can be added, and you can review all of those for your client application servers as well. So and Encache is very extensive in its support for client side monitoring. I hope that answers your question. Now I have run, actually I'm able to run two instances of Stressless tool, and you can see about 8 to 900 requests per second by each Encache server. So about 1500 requests per second on average are being handled. So that was a quick demo. I'm going to stop these tools. Next, I'm going to show you the actual features that you can actually utilize. So we have spent good amount of time explaining how Encache is very scalable, how it is deployed, how to configure and create a cache cluster. Now, next thing that I would like to highlight is how to utilize Encache in ASP.NET Core applications and what are the primary use cases. We covered different use cases, so I'll go get started with web front-end caching use cases within ASP.NET Core. So first feature that I'm going to highlight is Encache ASP.NET Core session caching. We have two options here. You can use, if you're already using sessions, and most chances are that you would be using iDistribute cache interface, so you can plug in Encache as a provider for session caching through iDistribute cache. You have standalone in-memory provider, you have SQL Server provider. Standalone is a single point of failure, it's not scalable. SQL Server is also a single point of failure in some cases, it's not scalable and it's very slow. Encache provider is super fast, it's in memory, it's very scalable, it's not single point of failure, and you increase capacity at runtime. So you can add more and more servers added, and you can achieve unlimited scalability out of Encache. So iDistribute cache, let's quickly review that. So here is our guest game iDistribute cache. All you need to do is services.add Encache distribute cache and then say app use Encache session. And here is a sample application that is going to do just that. And second option here is Encache session provider, which has advanced features, and I have a sample application for that as well. So let's actually focus on this primarily because our provider is much more feature rich, extensive in comparison to iDistribute cache. So I would like to highlight this, and as part of that you would see all the features that Encache provider, iDistribute cache provider also gives you. So coming back here, first of all you need Encache NuGet package, which I've already added inside this. So if we have ASP.NET Core sessions.encache, right, so that's the NuGet package. And let me just quickly come back here and review session here as well. And this has Encache Microsoft extensions.caching. So iDistribute cache session NuGet package is slightly different than the Encache actual session provider. So I'm going to focus on this one right here. all you need to do is, first of all, come to startup.cs. You have services.add ncache session, and it takes ncache settings in the configuration. And inside configuration, you specify all ncache provider settings. For example, I'm using ASP.NET Core Cache. Session app ID is an app ID attribute that gets appended with the cache item key. Your session ID becomes the cache key, and this attribute would get appended to it. So you can uniquely view sessions of different applications inside ncache. And then you set up some session locking. You can, if you set this to true, all right. So if you set this to true, that would allow you to simply lock a session so that concurrent access is not allowed. So you're only able to read session, write access is only granted to the current request which has the lock. And then we have detailed logs available, multi-site, single site and multi-site sessions are available. So all these features are only available if you plug in our ASP.NET Core session provider. iDistributed cache sessions are supported, but those are limited. So I'm going to run this real quick, and that will simulate an application which would eventually connect to this ASP.NET Core cache. Actually, let me stop this. Let me add my box as a client first. So here, all I need to do is add the client box, which is my box right here. There you go. I have all the configurations now, and now I can run this application one more time, and that should be allowed to connect to my cache cluster. Very good. So it will take some time for the first time instantiation. I think it had Firefox already running, so I think that was the issue. Let's see, it spins up this time. So this would create a session object inside ncache. I will see, if I go to the monitoring aspect, I would see one client connected. Once the provider gets initialized, that client would make connection to 107 and 108 and would create session objects inside ncache. At the moment, only one session object would be created because that's the main user. um, I'm going to be the one user that's logged in, but if you have multiple application users, you would see multiple sessions created inside ncache. But idea here is it's very simple, that all you need to do is add these two lines of codes, add ncache session, and then say use ncache session. These extension methods are going to cover everything. First instantiation takes slightly longer time. That's what we've seen in ASP.NET Core, but once it's the applications are up and running, we should be able to test it real quick. There you go, one client is already connected, so I think we're there. In the meantime, let me run a quick command which says export. This tool dumps all the cache keys which are currently there, so I'm expecting one session object added in the cache because one client is connected, and that should allow me to, there are two session, one from the previous attempt and one from this one is already there. There you go. So our session, this is a guessing game which allows you to guess a number, and it adds those numbers inside session, and it also displays those number. So let me just guess a bigger number, and that's how it's going to make request to ncache. So it's pretty simple application, but if you come back here, we have two items in the cache which are there, and you must have seen those two requests that I've just made onto ncache server side. So that completes our first demonstration, that you can plug in ncache for session caching. There are a lot of features. Single site, multi-site sessions are supported, session locking is supported, extensive logging is available. It's very secure. We have security and encryption on top of it. So it's a full package if you're planning to use ncache for session caching. Second feature here is ASP.NET Core response caching. In this, we have HTTP headers on the applications. You can choose to have page outputs cached, and you use Encache response caching middleware for caching. And it's again through iDistribute cache interface. So if I come back right here, we have this sample application. So all you need to do in order to use this is use this NuGet package, encache.microsoft.extensions.caching. This will cover sessions, iDistribute cache for object caching, and response caching in one NuGet package. And then next thing that you need to do is services.add encache distributed cache. So that's an iDistribute cache interface that gets plugged in, but we'll be using it for response caching. And in app settings, we have the cache names and some logging settings that we have set up. And if I come back right here, uh, you would have response caching configured as well. Services.add response caching. So this application, expecting response caching to be done, it would be done through Encache using iDistribute cache interface. So I'm going to run this real quick because it takes some time, and then expect it to be able to actually connect to Encache, and then will actually show you the data being added. If I show you the code, you can also specify configurations in line. For example, add Encache distribute cache, and you can say cache name, demo clustered cache, or ASP core cache, and you can specify all the settings in line, or you can just use the Encache setting and give settings through Encache settings right here. It could be through configuration or through inline settings. So it's very simple on that front. Let me run the I think I've already run it, so let's wait for it. And if I come back right here, now we are expecting two clients to be connected, because the response caching application would also make a connection to Encache, and we would see some items in the cache as a result of that. Any questions so far? Please let me know if there are any questions. It takes some time to run the samples, which I'm doing right now, but please let me know if there are any questions in the meantime.
One question came in. It was pertaining to Encache Encache security and encryption. How exactly is the data encrypted and kept secure?
Very good. So let me show this response caching sample, and then I'll show you the security encryption features inside Encache. So we have the application running, and as you can see, we have some items added. If I simply refresh this, we have the values being updated from here, and this page output content is stored inside Encache through our response caching. And if I show you the cache keys, we now have some more items in the cache, so 2 items in addition to session items which are already there. Now coming back to security encryption, those are very extensive inside Encache. We have security encryption features. There are many security providers that you can choose from. We have AES and DES providers, multiple of those. We have FIPS compliant encryption providers, and we have TLS 1.2 supported as well. So transport level security is also available with Encache. So that's what covers your encryption, where you can have end-to-end encryption between your client and server boxes. And then from a security standpoint, you can choose who could be cache admins, who could be cache users. And we have Active Directory based, LDAP based encryption security provider that you can plug in. So if there are any specific questions, you can send us an email and we'll walk with you and share all those details on how to configure these. But we have very extensive support inside Encache.
All right, thanks, Ron.
Very good. Okay, so coming back here, so this covers our ASP.NET Core response caching. Next feature is ASP.NET Core SignalR backplane. In this, if you're using a web form, you can use Encache as a backplane for it, and in comparison to conventional backplanes, Encache is a lot faster, very reliable, and very scalable as well. So here is the NuGet package that I've added, ASP.NET Core SignalR.Encache, that you can search. It's already installed. All you need to do, again, it's taking a cache name through app settings, and then here is the extension method. So if you have services.add SignalR, on that we have an extension method where it adds Encache as a SignalR backplane for ASP.NET Core applications. I'll run it real quick because it's taking some time. I think a lot of things are running. So I'll run this sample. So that would spin up a chat application, and it would be using behind the scenes, it's using pub/sub messaging of Encache. So for that, what I will really do is I will come back right here, and on the server side I would show you some performance counters which would allow you to specifically manage and monitor the pub/sub messages. And SignalR is using pub/sub messaging behind the scenes. So let me just say SignalR, right? So, and if you notice here, we have messaging section right here where we can see message store size, message count, delivered per second, expired per second, published, topics count. Topics are allows you to have separation of concern. Multiple applications using Encache as a signal backplane, they would have multiple topics created inside Encache. So topics of messages of a similar nature can be given to a separate topic. For example, you can create a topic for orders, you can create a topic for messages, customers. So you can have different messages in different topics, and subscribers connected to a separate topic are only given those messages relayed to them. So I already see some activity here, which means my application is up and running. So if I come back to server dashboard, now we have 3 applications running. I won't see anything in the regular statistics. I would see everything in the messaging statistics. So you can see message count. So there were some messages. Store size, so about 800 bytes. Message published, and then we have, I think, other parameters are not there because we don't have any expiry as yet. So coming back to my application, I would run another instance of this. Right, so I have 2 applications. Should have run it in incognito, but test message. As soon as I send this, it's sent here as well. Test message 2, and you would see that message on the other side as well, right? And if I come back right here, we have some activity going on here. So it uses pub/sub messaging behind the scenes, and it allows you to create a backplane. So SignalR itself, the use case for it, that it emphasizes on the push notification instead of user polling, which you can push content to your users, but with web form, there's a limitation that you can only push content to the connected clients to that web server. If you have multiple web servers, you need a central body, and Backplane by ASP.NET and ASP.NET Core resolves that. So you can use Encache as a backplane for that. It's a communication platform where all the messages are relayed to Encache, sent to Encache, and then Encache in turn sends to all the web servers, broadcasts it, and those web servers are able to transmit those messages to their end users eventually. So that's what makes it very fast. The overall architecture very fast because Encache is in memory. It's super fast, very scalable, very reliable, highly available. Okay, so I think we're good on this front. Any questions? Otherwise, I'm going to move on and talk about the data caching aspect. So we'll spend last 10-15 minutes on data caching, some of the features. There are a lot of features on this front, so I would quickly showcase some. So first of all, there are many ways you can use Encache for database caching or the app data caching, where you cache data inside Encache and you save trips to the backend database. If you're already using iDistribute Cache, although that's very limited, you can plug in Encache as a provider. And I have a sample application right here. Again, it's very simple. You need the NuGet package added. It's ASP.NET Core and my Encache Microsoft extensions .caching. So that covers iDistribute Cache. And then you need app settings, where you specify the name of the cache, and inside startup.cs you plug in services.add Encache distributed cache, give the settings through config, or you can use option 2 where you specify configs, all the settings through code directly. And in the index.html.cs we have some methods here where we're calling cache.getAsync. And one thing that you need to note is this iDistribute cache interface. For example, if I show you the getAsync, it's taking a byte array back. So it's not a serialized or deserialized object that you're getting. You have to do the serialization and deserialization yourself. what we've done in this sample, we actually taken this in such a way that we're serializing object before adding, and after retrieving we're deserializing it, right? So we're getting the string back through this. So that is something that we've done extensively, and that's what you have to do with Ncache directly used as your app data caching platform. You don't have to do all of this. Ncache would serialize and deserialize your objects automatically. You just need to mark them as serializable. So I'm going to run this sample real quick, and that should allow me to showcase the iDistributed cache interface as well. And finally, while this is being run, I would also like to build. So this is our iDistributed cache interface, and this is the second option here, which I'm showing right here, is the direct Ncache APIs. Here are our APIs. Alternatively, which we highly recommend that you get more control if you manage everything through direct Ncache API calls. You connect to Ncache using initialize cache or get cache in the current versions, and then you say cache.get to retrieve items, cache.add to add items, add async is also available, insert and insert async is also available, and then you can call cache.remove. So that's the second approach, which I will show once this sample runs. And iDistribute cache is supported, but our direct APIs are more extensive, feature rich in comparison. Any questions so far? Please let me know if there are any questions at this point.
So it's just a confirmation question about iDistributed cache. So the question is, can we use Ncache API along with iDistributed cache? And for that, where can we get the samples?
Okay, very good. So first of all, yes, you can use iDistribute cache. You must already be using iDistribute cache, so you can plug in Ncache as a source for that. So that could be a starting point. And then in addition to that, you can also start using our direct APIs in the same application. So yes, you can do that. We don't limit you to use one or other. All these use cases that we've discussed, session caching, response caching, SignalR backplane, iDistribute cache, or direct Ncache API calls, 5 of these features, you can use all of them in single application as well. So that's the beauty of Ncache, where you can combine all those use cases. Sample applications, all of these samples are they come installed with Ncache, right? So we're not using anything custom here. So all of these are available in program file sample Ncache samples. These are published on our website as well. Very good. So this sample has run. So if I reset cache time, it would do that. And if I quickly come back right here, I would showcase the cache keys. And now you would see some more cache keys. I think some items have been expired, but you see cache time UTC. Some response caching objects must have been expired. So that's how you use the iDistribute cache interface with Ncache. Now I will showcase the direct Ncache API calls, which we highly recommend. That is something that you can also do. So for this, you can use the alachisoft.ncache.stk NuGet package. That is our complete SDK, which brings in the entire client-side resources, and all the features can be exposed on the client end using this SDK. And based on this, I can say include these namespaces, alachisoft.ncache.client, and you can also include runtime because there are some advanced features that you can use through that. iCache interface, this is our own interface, unlike iDistribute cache, right? So we have a lot of features, as you can see, in comparison. And within these we have multiple features as well. So these are some objects on iCache. So you can initialize the cache. Initialization is done through Ncache client.cache manager.get cache. So that's how you get connected to it. You get a cache handle, and using that cache handle, you can set up some time-based expiry, give the object, which is customer in this case, add object to cache, and we're getting a customer. Then you say cache.add, a key value item is added. So customer object would automatically be serialized while you would add into the cache. And then retrieval is through cache.get, update through cache.insert, where you can change some values, change expiry time, and then you can call cache.remove to remove data as well. So within this sample, if quickly. All right, so it's getting the cache from the app settings. If I give the name of this cache to be ASP core cache, this will start using the same cache for data caching as well. And you've already seen this where I have used same cache within different applications, but if it's one big application using all these features in conjunction with one another, in combination to one another, that's also supported. So while this is being run, there are many features. I'm just showing one or two in the samples because those are just basic operations. And this would add some data in the cache. It may not stop at any point in time. I'm not too sure, but let's see. In the meantime, if I show you, one client is connected, it has made some operations, right? Let's hope it, all right. Let me put a breakpoint somewhere. And run it one more time. So what it really did was it actually initialized the cache, added an object, retrieved it, updated it, retrieved it again, then removed it, and then cache got disposed. So before dispose, I've put a breakpoint, so hopefully you can now see that initialized, added, fetch, details updated in the cache. So all these methods have been executed. So that's how simple it is to run this sample. All you need is the NuGet package and the uh, you know the namespaces to be included, and then play around with different APIs, which I'm going to show here. Many features are available. I'm going to spend last 5-6 minutes on different features which are available as part of our direct in-cache APIs. So you can use time-based expiry. Absolute and sliding expiration is available. Absolute is when you give a time upfront, and data would be removed after that time elapses. Sliding is if you keep using that data. Let's say you have a 10 minutes of sliding expiry. If you don't access that item for 10 minutes, only then it's removed. Otherwise it would stay in the cache if you keep using that object. You can synchronize your cache with database. Any change in the cached item content, right? For example, any the cached item, any change in the database record. If you've cached items which belong in from the database, any change in the database would invalidate the item from the cache. And we have SQL dependency for that, which is event based. We have DB based dependency, DB polling dependency, which is polling based. It polls for changes, and if it finds some records in the database have been changed, it would remove the corresponding items from the cache. .NET CR store procedures, where you can make direct in-cache API calls from the big database servers directly. You can synchronize your cache with non-relational databases as well. File dependency is available. You can make cache items dependent on files, or it could be also custom dependency where you run a code, register within cache, and that would determine whether that item has to be expired from the cache. So based on your business logic, you can expire items from the cache. We have key-based dependency. You can use that to handle relationships between cached items. So one-to-one, one-to-many, and many-to-many relationships can be managed inside Encache. Server-side support, code support is very extensive. You can use cache aside pattern, or you can use read through and write through pattern, where you read into the cache from the cache, and if data is not in the cache, you can read through the cache by running your provider. It's an interface that you implement and register with us, and you can read through the cache and get that item or record from the backend database. And write through is opposite of it, where you update the cache, and then you can also automatically update the backend database by calling your write through handler, an interface that you implement and register. And write behind would update the backend database asynchronously, which is very fast in comparison, where you don't have to even for write operations, your cache item is going to be only updated in the cache, and your application returns, and behind the scenes Encache would update the backend databases. Groups, subgroups are available. You can create logical collections inside Encache. Tags are supported. You can attach keywords on the items, and you can retrieve, remove, or fetch, or even play around or search items based on their corresponding tag. SQL-like searches are available. SQL and link searches are supported. You can search items based on their attributes. You can run a search criteria which can go something like select products, where product is the object type, and say select products where product.price is greater than 10 and product.price is less than 100. So based on your specified criteria, Encache would formulate the result set in your applications. And link queries are also supported. These are parallel. Data indexing is supported as part of this. You need that as a must. That makes it very fast searching out of Encache. PubSub messaging and events is a separate feature. We have async event driven PubSub messaging platform. We have criteria based continuous query where you can map a data set and get events out of that data set. For example, you can map all products where product prices are less than 100. So that could be your data set. Any change in that data set, you would get notified. Key-based events are available, so you can get notified if an item gets updated or removed, or it could be cache level where all items are being monitored. And finally, some details about Encache clustering. It's based on dynamic cache clustering protocol. Encache allows you to add or remove servers on the fly, so there's no single point of failure in case any server goes down. It's managed within the protocol. If you add more servers, it automatically starts using newly added server. If a server goes down, you have no downtime even in that case. And there's no single point of failure, primarily because there are multiple servers hosting this cache. Adding and removing servers is seamless as far as your applications are concerned. Gives you 100% uptime, a highly available cache scenario. And then we have already covered topologies. We have some client cache, WAN replication features. You can have site-to-site replication between active-active or active-passive sites. That's also managed. So the list goes on. I think we've covered a lot of details, and I wanted to give you a quick overview of how you can actually utilize Encache in ASP.NET Core. So we're already heading towards the end of this presentation. I think 1 hour marker. I think let's conclude this at this point. Please let me know if there are any questions so far. Otherwise, I'm going to hand it over to Zaire, and then we can take it from there. Any questions?
We'll leave the floor open for about a minute. If you have any questions or you're still thinking up of some, feel free to toss them out.
And while we're at it, we've pretty much covered all these features that you're seeing: ASP.NET Core Sessions, response caching, SignalR backplane, I-distributed cache data caching, and direct Encache API calls. And we even have sample applications for PubSub messaging. If you're interested separately in this section, you can get a separate sample application available as well.
So to answer a question that just came in, will this presentation be available later? Yes, it will be. You will be able to not only get a recording of the webinar, but also we'll have the slides available if you'd like to download and use those as well. And you will get an email linking you to the recorded webinar once it's ready. So and you can always come to our website once it's live, and under recorded webinars you can find them. And another question came in is what is the difference between I-distributed cache and Encache ASP.NET Core Session Store Provider?
Okay, so I believe the question is more focused on difference of session usage through I-distributed cache and session usage through our cache provider. So on a high level, I-distributed cache is limited in terms of its functionality. Encache provider gives you more control. First of all, you can use session locking. I-distributed cache session is non-locking based store. You can use single site and multi-site sessions. That's a specific feature inside Encache which is not available in I-distributed cache. Although Encache supports I-distributed cache session provider as is, it gives you a lot of benefits on top of I-distributed cache. But when we compare I-distributed cache sessions with Encache and Encache sessions for provider with Encache, that's where Encache provider has a clear edge. Then there are a lot of features such as session sharing between different applications. There is a session app ID attribute that you can specify. Your exceptions can be logged into event log, cache logs can be created, client logs can be created. So there's a huge list of features which are which are different between these two. So it's highly recommended that if you're using session caching with Encache, so I would personally recommend to review our session supervisor in comparison to iDistributed cache session with Encache, because you get a lot of benefits.
And one more to toss is grouping data. So how can grouping data make that data retrieval easier?
Right, so you attach
how does that work?
you attach a group to multiple items, and then there are group based APIs where you say get group data, and you get all those items at once. So you don't have to give keys of those individual objects separately. So it makes it with one API call, all the group data can be retrieved. You can remove data in one API call. So that's how retrieval and update process is easier in comparison.
Okay. Any other questions? Anyone? All right. That concludes our webinar. Thank you very much, Ron, for taking out the time and explaining all these things and answering all these questions. And we will definitely have the recording of this webinar and the slides available in the coming week. So please keep an eye on your emails, and also feel free to come back to our website once it's live. And once again, thank you to all of you for coming and attending. We had a great turnout today. We hope all of you stay healthy and safe and have very productive weeks this week and next week. And we look forward to seeing you in our next webinar. All right.
Thank you, everybody.
Bye, everyone. Bye, Ron. Thank you.
Bye-bye.